Hello, everyone, and welcome to the Neural Network podcast. My name is Vasudevan Lakshmanan,
And I'm Armaan Priyadarshan.
and today we're joined by Dr. Heffernan, an amazing professor at WPI who has been specialized in machine learning and AI methods. Dr. Heffernan, would you like to introduce yourself today?
Yeah, I'm the William Dean Smith, actually professor of computer science. I actually advise students in data science and other areas. And I guess I'm best known for having created the assessment system. And my PhD students are right now working on using large language models to give better feedback to middle school students inside the assessment system.
That's really cool. Could you mention a little bit more about your field of research and maybe some other previous projects?
Yeah, I guess the um, I guess since you asked me to brag, actually, I'll brag for a second. Actually, my students have done a lot of great work, actually causing us to win a lot of external actually acclaim. We've raised more money than anyone at the university, over $100 million to fund the creation of assessments and a whole bunch of different science projects related to using assessments. And my students have gone on to be professors at Berkeley and University of Florida, as well as industry like Amazon, Google, Apple, etc.
Wow, that's honestly incredible. And would you like to elaborate on the experiences you've had over the past few years with these students? So, what kind of specific projects you've helped them mentor or like you've worked on collectively?
Yeah, sure. Like right now, we just were funded, and we'll start tomorrow, actually, a something that was essentially a $5 million project. Um, we all know large language models exist, actually, and so my students, um, Eamon Warden, actually in particular, is actually training on WPI computers, new large language models for the purpose of actually providing students a more interactive experience inside when they're working on their homework. Basically, instead of just spewing hints at you, we'll actually ask you some questions the way a human tutor might. And so I teach the artificial intelligence class here at WPI, but I don't really believe in artificial intelligence. And so these dialogues, some people would say those are like humans, but really we're just going to break problems down into steps, and maybe we'll be a little subtle enough to be able to notice, are they getting stuff are they getting stuff right or wrong, actually, and how they're doing. And so um, I could say more about actually the training of large language models because we're doing that internally. Do you want to hear about that?
Sure, yeah.
Okay. Well, so you might or might not have heard about uh, back in May. You might have heard of the leaked Google memo, where it has we have no moat. This was from a Google executive that was writing to his buddies at Google, saying, "Hey guys, we're in big doo doo. Actually, we have no moat anymore. That means we have no defense. We used to think because it cost tens of millions of dollars to actually scrape the web and then actually train up the billions of parameters necessary to put into a large language model, that actually we had a huge advantage. No one's going to be able to actually compete with us, other than the few people that actually have the ability to do those two steps. Turns out multiple people, including actually Meta, have actually released actually large language models like Llama. It's called Llama, and so Percy Lang actually in May actually released a paper where he took 150 different tasks that actually you could ask GPT for, and with $600 worth of paying GPT to actually do some of these tasks to build up some data, he made actually systems for these 150 different tasks that were close to almost as good as what GPT was doing. And then actually you have that internally. And so Google was worried about stuff like that. And the fact that you can now actually run these Llama 2 large language models on cell phones. And you can train them up actually with processes like LoRa, which is a way of leaving all the parameters intact from, say, the meta model, but then actually learning a relatively small number of parameters on the order of like 20,000 parameters instead of actually 6 billion or everyone's it's rumored to believe that actually OpenAI's actually 4.0 actually has about 1 trillion parameters, maybe 1.7 trillion parameters. Most of these large language models that are actually in the open source space are somewhere between a single digit parameter, like 2 billion parameters, to maybe 170 billion. No one in the open source world is actually playing with models as big as actually OpenAI. That would make you think that actually we couldn't possibly do very well, but that would be wrong. It's also the case that with application-specific things, like the fact that here at WPI, over 1 million students have actually worked inside ASSISTments. So we have all this data that we can then actually fine-tune our model that no one else actually has access to. So it's not just us, but actually the open source movement actually is a pretty exciting thing to be participating in.
Yeah, thanks for the context. So for your model, you mentioned that you were fine-tuning. Are you guys training from scratch? Are you like fine-tuning existing architecture?
No, pretty much everyone actually just is leaving the existing models the way they are, but then find this LoRa process, low rank adaptation. That's what LoRa stands for. Is a way of leaving actually the model intact that you start with. Typically Meta's model, but actually there's other models that are also actually available. The United Arab Emirates actually put out one called Falcon, and it looks like different countries are getting excited about actually having models in their own languages. There's two actually in India that have actually come out. It's not clear those guys are going to be open source the way these other ones are. But no, we don't want to actually do the main task of scraping the web and then actually fine-tuning the 7 billion parameters that are maybe in, say, the one of the variants of Metas. No, you actually learn this other set of parameters that allow you to customize your task. And so that's how that works.
And for the training process, what are you guys using to train? So I think you mentioned you're training with WPI servers. So how exactly does that work?
Yeah, so we actually have machines here at WPI, and so I also have some machines in our own lab, and so like my PhD student actually has several different, so he has multiple different actually avenues to pursue this research, and so you probably figured out or heard that actually it's really the graphical processing units are actually what
Yeah.
everyone's doing all their deep learning on. And so, and those are actually those are expensive. And so, but we have access to actually some of that stuff. We're no OpenAI actually, like, who has a budget of computing that is like through the roof. But yeah, the PhD students and the undergraduates here at WPI who have actually been helping me are um, are using it. Like, for instance, there's a group of actually undergraduate MQP students that we asked to test different actually freely available large language models. Have either of you ever heard of Hugging Face?
Oh yeah, no. Actually, I had a research project at Mass Academy just this year where I trained like my own language models and I based it off like Hugging Face and GPT-2 checkpoints. So that's pretty interesting. So I'm like kind of curious about like all the different processes you guys went to train with.
Yeah. So I think actually I think the model we're using right now is actually either either the French Mistral one or actually there's a llama model that was actually trained called Wizard
Yeah.
and on a bunch of math content. We really care about math. Uh, backing up, this has moved really fast. Like I wrote a paper in December of last year where I basically said GPT 3.5 for the task we care about really stinks. It makes 50% math errors. And we are asking GPT, please, here's a problem. Here's the answer. Please give me an explanation that we could give to a child. Everyone else cares about, can GPT solve the math problems? We don't care about that. We have all the answers. The question is can you make interesting explanations that make sense? Anyways, so the paper we wrote in December, so we reported this 50% error rate. When 4.0, actually OpenAI's 4.0 came out, that error rate actually dropped to 5%. And so
Wow.
it was drastic, right? And so like we were no there's in fact actually I was ready to actually take my own personal stock portfolio and bet against OpenAI. That's how actually luckily I didn't because OpenAI is rocking it and has blown me away because I actually thought I don't want to do any of this large language model stuff. But now we're it's now matured enough that it's time to do stuff and therefore time to write grants to actually go get the $5 million I just referred to actually do this sort of work and to do the hard work necessary to then make like take these LLMs and turn them into useful applications and so for students and for teachers. Yeah.
Yeah. So I think like for math, you mentioned that LLMs used to perform significantly worse than they do now. I think for like a current project that I'm working on at Mass Academy again, we're considering using like a chatbot powered by an LLM to help people self-studying for PC calculus. And based on
Uh-huh.
that, like you could have like give the problem or give the LLM like a certain kind of problem you want or a problem you want to get like a similar problem to, and it would generate a problem like that as well as like a solution that would help you work your way to the answer. So we were thinking about that, but we thought that like it wouldn't be feasible just because LLMs aren't generally good at math. But I think that's completely like not the entire truth according to like the GPT-4 performance. So like, what do you think would explain how much better LLMs are getting at math?
What explains actually how they did it? I'm not sure I have anything super interesting to say about it. How did GPT actually, how did OpenAI do that better? I don't feel I actually have great insight into that. I do know there's two big benchmarks that are commonly used for mathematics. One that is actually more kind of like a K-12 that tops out at like eighth grade. And I know on these benchmarks, most of these it's pretty easy to get one of these even open source LLMs to get well over 90% right at actually getting those math problems right. The harder stuff, calculus, that's harder actually. And so there's this other harder benchmark set. I think I think I was just reading a paper on the Gemini. Gemini is actually Google's actually LLM, and that LLM is not actually open source. But I think they were reporting um, beating OpenAI's 4.0 actually stuff on their math performance. And uh, so yeah, I'm in the position of kind of looking and saying, oh, okay, we just got funded to essentially do a 5-year long project.
Mhm.
These LLMs are only going to get insanely better quickly, right?
Yeah.
Yeah.
It is moving so fast. Like the NeuroIPS, which is actually a place where lots of these papers are published at where all these neural network actually things. Um, um, I think last year it was like 9,000 papers. Actually, it's overwhelming in the amount of volume of stuff that is actually happening. And But our specialty here at WPI and in my lab is actually figuring out how to make applications that actually would be useful. Like for instance, like we're trying to figure out how to actually give some large language model technology to teachers. And Teachers could actually do all sorts of things with ChatGPT that we actually could help them do, but they don't actually have it's like it is it's people haven't built out the applications necessary to give to teachers that actually make their task easy. Like for instance, one of the things, so I do this project with Christina Heffernan, my spouse, and like last night she was putting into our grant actually information on, hey, we now just ask GPT to take these open-ended questions and categorize them so that a teacher could see, hey, I got 25 kids sitting in front of me. Here's actually 5 ways of solving this problem using unit rate that these kids did. There's 7 that actually did this equal comparison thing. These are 2 both valid ways of actually solving this proportional reasoning problem. And here's actually 2 different clusters of kids that actually are answering this in different ways. Some that are trying to use this unit rate strategy and then mess it up. And so in theory, a teacher could actually go take actually all of their kids' answers and actually go to chat GPT and say, hey, here are my students' answers. Could you please, and here's the problem, can you please categorize them for me? But that's like really laborious. Like we already have them all. Should have to like copy them over and so to a large degree, what we're building in my head is applications that actually like add a layer of actually utility. Like our secret sauce is not we're going to beat OpenAI at the task. Actually, does that make any sense?
Yeah, for
Yeah.
sure. The applications of LLMs are growing like ever relevant, and we know that firsthand. We've been seeing them just about like everywhere, even in school.
Yeah.
Yeah, absolutely. And talking about like the different forms of research you've done, primarily with education, could you expand upon how your journey as a computer scientist began and how you got involved in the educational system and research?
Yeah, sure. I actually when I was an undergraduate, actually at Amherst College, I was very interested in human tutoring. I actually joined a group called Students for Educational Equality. I wound up actually going to Princeton the first year. Wendy Kopp was starting Teach for America, and so I wound up recruiting undergraduates at Amherst College to go into Teach for America. And I wound up actually studying computer science and history. Um, and when I was done, I actually joined Teach for America. And so I taught 2 years in middle school mathematics and science before actually applying to get to Carnegie Mellon to go get a PhD, well, to a bunch of places, but I wound up going to Carnegie Mellon in their computer science department to work with people that were already in the space of building what some people call intelligent tutoring systems. And so after doing some science there with my advisor, we got excited, or I say we, it was really our project has been something that my wife and I have been doing for a long time. And so we got our first ASSISTments grant, and that word assessments is just blending instructional assistance and assessment. And so and we keep actually writing grant after grant after grant where we're like, oh, now that we have this, how can we actually use this to do new science? Like we actually had one grant where we're like, let's look at the students that unproductively persevere. There's some kids that bang their head against the wall. They work really hard, hard, hard. They are not learning. Actually, what should we do? Actually, most commercial entities don't even want to talk about such kids. That actually, the kids that actually work hard in our system and they don't learn, like that's just an embarrassment. But we're a scientific. I don't know. I'm a scientist, so we actually go look at that,
Mhm.
and we and we have the guts to actually admit that happens to our ed tech product too. Like actually, and so anyways, um, we have different projects that have looked at actually going into assistance classrooms and actually looking at which kids look like they're bored, confused, frustrated, or engaged, or in gaming. And a person is holding a little holding their iPhone and making these judgments timed to actually the judgments that are happening, so they can then actually use machine learning and actually build a detector of, hey, which kids look like they're bored, frustrated, gaming, etc. And so that we must have 10 papers related to, well, it turns out you could use these detectors actually, and they give you a lot of information actually. And interestingly, actually, kids that get frustrated a lot, you might think actually they have lower state test scores. Turns out, no. The kids that are good enough, here's my take, the kids they're persistent enough to demonstrate frustration are also the ones that also persevere through. And so there's anyway, so we have a body of work actually there. And so in theory, we could be using those detectors to make our tutor actually, or do you want to call the thing we're building a tutor? I don't really like to call them. My advisor likes to call them intelligent tutoring systems, but I usually don't use that name. But actually, but the piece of software we're building, we could make it a little smarter actually, so we could kind of, I don't know, among other things, tell the teacher who looks like they were really frustrated. Gaming is really easy, like who actually looks like they were just trying to get through the system without really doing anything and not having to learn. But those are some examples.
Thank you, Neural Network listeners, for listening to part 1 of our interview with Dr. Heffernan. We hope that you were able to take something new away from the conversation and learn something cool about the amazing work that he does. Please tune in next week for part 2 of our episode and our interview with Dr. Heffernan. That's Vasu, Armaan, and Dr. Heffernan out.